Hi, welcome to my workshop. My name's Darren. Now, something I try to do with my YouTube videos is try to make them for as broad an audience as possible, at least, even though they're always about woodworking or 3D printing. This one, however, is going to be specifically for people with a Carbetec TS-C250 HA table saw. Now, with my previous table saw, I just built my zero clearance insert out of wood, no problems, worked well, out of plywood it was. This one I wasn't able to do it because the gap around the edges is only 3mm. You'll see that in the tick. I wasn't able to get aluminium in the size I needed without a checker plate pattern on it, certainly not without some in-depth searching. I did have a go of making my own out of acrylic, and it worked. It could fit and everything, but the first piece of acrylic I tried, when I started cutting it to shape, it just shattered, and so it put me off using this because I was worried that it would flex and hit the table saw blade and again just shatter. So while you could make one out of acrylic, I don't recommend it. So I really wanted a 3D print one, and I couldn't until I got the Prusa XL. So if you've got a large format printer, I have a model for you, and you can print up your own zero clearance insert plate. Alright, since I bought this table saw, I've wanted a zero clearance insert plate for it. Makes cutting little pieces and thin pieces much better. You get less tear out, of course. You can see I've already removed my riving knife, and that's another thing I'd like to be able to do with the zero clearance insert plate, is either have a small, very small riving knife behind it, so as I can make cuts that don't go all the way through the board, or better still, a removable riving knife, or actually, third option, or yet another zero clearance insert plate with a riving knife and one without. Those are my options. Now, the main problem I've had, and the thing that's been slowing me down, as you can see, the clearance on that lip is only 3mm. So a 3mm piece of wood wouldn't be very strong. Now, the original, of course, is made of aluminium, so the thought of making one out of aluminium hadn't escaped me. But trying to get one without checker pattern on it and 3mm thick was actually pretty difficult. And if you have a look at the underside of this one, it's actually got these ridges to keep it rigid, or you could call them ribs if you like. And you can also see that I've actually put tape on mine just to make it ever so slightly thicker, because it was one tape width short of the top of the table saw. So I printed this fella up in PETG, and so you might be wondering why I've already got the groove in there. This is supposed to be a zero clearance insert. You're supposed to raise the blade and cut your own groove. Well, what I've done, I've made the groove ever so slightly thinner than the curve of the blade, just by the edges of the saw teeth. And the reason for that is you get less plastic build-up when you raise it up through. I would recommend printing with 3 perimeters for that reason, because you're going to be shaving off the outer perimeter and reducing its width, but well worth the effort because you get a nice tight fit without heaps of molten plastic to deal with. Now, this one in PETG shrank a little bit. So here's something to keep in mind. If you want it in PETG, you're going to have to scale up. I've ended up doing mine in PLA. What I've done, again, I've got 2 models. I've got one that's the exact size and one that's ever so slightly bigger to allow for shrinkage, which is what I've printed here. So we're going to put it on the table saw now. We're going to screw it into place and see how we go. Okay, so I've unplugged the table saw from the wall, lowered the blade all the way, removed the original riving knife, and so now we're going to fit the insert and raise the blade up through it. It's printed thicker in the middle to keep it rigid, and to allow it to fit, there is a notch in one end. Also, obviously, we want our slot to light up with our blade, so this only goes in one way. It's pretty easy. If you want to think of that as an arrowhead, this is for our dust, but yeah, that'll point towards the front of the saw. I'm going to pop it in there. Now I'm just going to pop the screws in. I'm going to put them all in loosely first and then tighten them the rest of the way. I'm going to use a manual screwdriver. I'm not using a drill. I'm not using an electric screwdriver, I'm using a manual one. And that's because I want to feel how tight I'm doing it. So what I've done is I've tightened the screws till I've touched the bottom, and I've just taken them back a quarter of a turn. That'll give us a tiny bit of jiggle in here, just a tiny bit. And what we're going to do now, still unplugged, is we're going to raise the blade. I've raised the blade now until it's just starting to just pip in to the bottom of the slot. Alright, it's just in there. So now we know that they're as lined up as they're ever going to get. Now we can tighten our screws down the rest of the way. Oh, beautiful. Okay, and that should be either perfectly flush or slightly below the edge. Good way to test. You don't want to get stuck as you come across or as you leave, basically. That's the most important part. Okay, so now what we're going to do is we're going to lower the blade again, so as when we turn it on, it doesn't start in contact with the plastic. And then we're going to turn it on, raise it up very slowly up through here until we've brought the blade up all the way. Then we're going to clean off any tiny bits of plastic, and then we'll look at fitting the riving knife. And just in case my dulcet tones have bored you to sleep, wake up, put on your PPE. Okay, here we go. We're going to raise it up very slowly. So I'm just going to run over it with a scraper, like this. And then I'm going to give it a little chamfer run there. Take off any dags. That's it. Alrighty. In place of a riving knife, I'm going to use these MJ splitters. There's a whole little jig that comes with it that we're not going to use. Or actually, if you want to use it, go for it. But obviously, I've measured out the holes already. They're already there. Again, I've made them tight. There is a drill bit that comes with this. You want to put that drill bit through the hole and just clean it up. Make sure it's a really nice tight fit. And then they want you to chamfer these 1/32. So what's that? Just over 1 millimeter. Anyway, so I've chamfered them slightly as well. Now theoretically these holes should line up perfectly with the kerf, but we do have different width little kerf splitters here, or little MJ splitters to use. So it's to make sure we get the right one and to double check that these are lined up and we're not twisted somehow on the table with this, although we shouldn't be. I am going to run a piece of timber through here. We're going to make a kerf or a cut through the timber, and we're going to use that to line these up. Make sure we've got these in the right way. Here we go. We're going to make that little cut I was telling you about. There's my Okay, so there's our holes, and they did line up very nicely with our kerf. So now we're going to select the correct kerf splitters, or MJ splitters, and pop them in there. Okay, you can see here they've got different numbers of pluses on them. The ones on the left have got 3 pluses, and the ones on the right have got 2. On the other side have got MJ written on them, and these ones have got a single plus. Alright, so what that means is how far away from the center point they stick, and that's going to determine which ones we use and which way we position them in the kerf. So what does that mean? Well, if something's not tight enough against the fence, we might have 3 pluses pointing towards the fence, because that'll be a thicker side facing the fence and therefore make it tighter. We're just going to have a look and see how our kerf lines up with that. Okay, so this one is with the 3 pluses towards the fence and an MJ facing away from the fence. That's the one that fits best for me. So I've got 2 of those. These go in fairly easily most of the way, but the last little bit, I suggest you get yourself a screwdriver. I'm using a Torx, but anything with a round shaft that fits through will do. Pop it through and put your fingers right up either side, so as you're not leveraging it. We don't want to bend this, we want to push straight well, you want to push it straight down, and we'll do that. Just there we are, and that's seated beautifully. All right, so we've got our two MJ splitter kerf keepers. We've got our zero clearance insert. Let's give it a test. Now this should be a good test piece. This is only 6.6 millimeters thick, radiata pine. So if anything's going to split along the edges or have a bit of tear out, it'll be something like this. So it'll be interesting to see what sort of cut we get. But of course also we're going to be watching the off cut, which is the test here. Make sure it doesn't go down inside the table saw. Okay, here we go, the big test cut. So I would definitely call that a success. There's, as I say, no tear out. It's done a nice cut, and this super thin little piece did not end up inside the table saw. So there we are. If you have one of these Carbetec table saws and you want a zero clearance insert plate, I'll leave a link in the description for you to download the model and you can print one up. Right, that brings us to the end of another one. Now I did mention as I was filming, hopefully I haven't cut it out, that I will make two models available. One with the exact sizing that you need, so as you can allow for your own shrinkage, what have you, and one which is just slightly oversized, which I've used for the PLA model, which I've used on the table saw. PETG is probably the ideal choice, and with that textured plate like they have for the Prusa's for PETG, you get a beautiful finish on here, which is actually really low friction. I've used MJ splitters here in mine. If you don't want to do that, provided you get them in perfectly straight and glue them in just right, you can use drill bits, not hole drill bits, but the shank, the base part of a drill bit that's the same diameter or ever so slightly narrower than the kerf. I have done it before many years ago and it worked for a long time, until eventually I bashed it out of the board with a piece of jarrah and ended up doing them with MJ splitters. You could of course print your own versions out of plastic for it, but I do like the security of knowing there's a piece of steel inside there, and they are removable if you want to cut a groove. I don't want to pull the MJ splitters in and out all of the time, so what I'm actually going to do instead is I'm going to print up another base plate and have one with the MJ splitters and one without. Hopefully that's of some help. Have a great day and I will catch you in the next video. Bye for now.